European Space Centre in the Netherlands. Here's what's ahead on this special edition of Inside Europe. Reaching for the sky. We'll take a look at the European Space Programme and we'll talk to a scientist and a future astronaut here at the European Space Centre. Inside Europe. This week we're at the European Space Centre at Noordwijk in the Netherlands. The centre, with its major test launch facilities and impressive areas of space research programmes, is the nerve centre of the European Space Agency. The agency was set up in 1975 to promote cooperation between European states in space research and technology. In the next half hour, we'll be looking at how European countries have been pulling together, not just in the area of space, but also research and technology in general. For our cover story, Inside Europe's Richard Goslin takes a look at the European Space Agency's latest and biggest ever venture.
It's now over 2 years since the darkest of days for the European Space Agency. 10 years' work and over $7 billion went up in smoke in French Guyana as the Ariane 5 rocket exploded less than 40 seconds after blastoff.
Tous les paramètres propulsifs sont normaux et la trajectoire est normale.
The disaster forced the agency, known as ESA, to rethink both its strategy and its budget. But 2.5 years later, there are reasons to be cheerful again. First, a public relations triumph for Spanish astronaut Pedro Duque, who flew the ESA flag on the recent shuttle mission with John Glenn. And last month, the agency's involvement in the International Space Station finally saw some real progress, with the first components blast-off from Kazakhstan. The launch of the Zarya module ushered in a new era of international space cooperation. Europe has joined forces with Russia, the United States, Canada, Brazil and Japan to get the station into orbit, at a conservative estimate of some $30 billion. Observers say the project is an example of different European nations working together with a common goal.
Cooperation has been very useful, and it's a model of European cooperation, but with some of the problems of European cooperation.
Those problems include agreeing on the participation and financial contributions of the 14 nations which make up ESA. France, Germany and Italy lead the way, putting up almost 90% of Europe's $3.7 billion contribution. But as with the question of European monetary union, Britain has decided to stay on the sidelines, for now.
The key point for the UK is that it decided some 10 years ago that it wanted to concentrate what limited funding it had into other areas, and in particular into Earth observation. And it's also very keen to put money into near-market activities. And obviously there is some debate as to whether the International Space Station does actually give a return of investment.
Last week's launch of the shuttle Endeavour was just the second of an estimated 45 missions to construct the space station. That's prompted some experts to label the project as a bottomless pit for funds. But it's something ESA didn't get into lightly, and given its track record, it should be well represented when the project is finally completed.
One merit of the Space Agency, of the European Space Agency, has been that they have never abandoned the project once they have committed to it. And I think that is an example to NASA, which is all too keen occasionally to drop a project if something goes wrong financially.
And as for the International Space Station, it's so far, so good.
Houston Endeavour, we have capture of Zarya.
Richard Goslin, CNN London, for Inside Europe.
Well, we're here today at the European Space Centre, and behind me you can see the prototypes of some of the Ariane rockets which have gone into space. I'm joined now by Jean-Pierre Le Breton, who is one of the science managers here. What kind of projects do you work on?
Well, I'm working on the Cassini-Huygens mission, which is on its way to Saturn at the moment. It's a joint project between NASA and the European Space Agency.
And why Saturn?
Well, Saturn is one of the major planets of the solar system, and exploring Saturn, and especially its moon Titan, which is the main target for the Huygens probe, has provided element of the mission, will tell us a lot more about the planets, of course, but also about the Earth. For example, Titan has an atmosphere which is in many ways very similar to that of the Earth. So by Studying Titan, we learn more about the Earth, for example, about the greenhouse effect, how this effect will work on another planet, Titan, will teach us how to know it better on Earth.
And what about the nature of the cooperation between you and NASA? How does that work?
Well, I can only speak for the cooperation we have since 1984 on the Cassini-Huygens mission. It is excellent. We have a very good cooperation, which is really, one of the major reasons, I think, is the excellent cooperation between the scientists on both sides of the Atlantic, and this makes the mission very, very exciting.
And when you look into the future and for the remainder of your career, what do you see as the great challenges there that you'd like to deal with?
Oh, that's a very difficult question. We are, for example, at the moment studying a very ambitious mission like returning a sample from the surface of Venus, also returning a sample from the surface of Mercury. Those are very ambitious missions, which I hope may be realized before the end of my career.
Jean-Pierre Le Breton, thank you very much indeed.
Thank you.
Stay with us on CNN. After the break, Inside Europe, we'll have an interview with Edith Cresson, the European Commissioner for Research and Technology. And Inside Europe, well, this week we're at the European Space Centre in the Netherlands, and we're looking at European joint ventures in the areas of space research and technology. Now, that cooperation is a very high priority for the European Union, which gives its third biggest budget to research and technology. Well, our Brussels Bureau Chief, Patricia Kelly, spoke to the European Union Commissioner with responsibility for research and technology, Edith Cresson. She first of all asked her why cooperation between European countries is so important.
Well, research and science in general is going faster and faster and requires more and more money. So it is, in some areas, quite interesting to put together people from different countries of Europe and to have people working in universities or in big companies or research centers from different countries of the Union. They make teams, and then they would bring each of them something quite different. So we have 4 big fields of action. The first one is everything about health, biotechnologies, and science of life, and so on. The second one is the technologies of communication. The third one is how to be more competitive. And the last one is about environment and energy. And then those are the big chapters of our research programs. And inside those chapters, as sort of a horizontal way, we have big teams or ideas that people are interested in. For instance, the fact that the population is becoming older. How are we going in the years coming to take this problem in charge? This includes problems which are of health, of course, but also industry, also lodging, also medical care, things of that sort.
So how difficult is it for you to get money to be able to fund all this research?
Well, the money comes from the member states. That means that instead of spending the money at home and doing the thing alone, we decided to put it together in order to have better results with the same amount of money than if we did it each of us at home.
How does European research compare to the United States at the level that you're talking about? Can you say that the European Union is truly competitive with an area like the United States, or indeed Japan, or anywhere else in Asia?
Yes, the European research is certainly competitive. But the problem that Europeans have is the difficulty that they always have had to transmit what they find into something that you can use or sell. First, then you have to make. So this thing that we call innovation is certainly too weak in Europe at the moment. So we try to help also. It's not only a question of money or risk capital and so on. It's also a question that our universities have too long been separate from the economic field. They've always wanted to live apart. And this, I think, is a mistake. So we try to in those teams that are created for those purposes, the research, to bring those unities which are different, such as universities, companies, and research centers, to work together.
That was Edith Cresson, EU Commissioner for Research and Technology, talking for Inside Europe to CNN's Patricia Kelly. And now we take a look at a practical example of how Europe can pull its technical resources together for the common good. Inside Europe's Tim Lister reports on Europe's efforts to protect itself from a nuclear disaster. Inside Europe. This week we're at the European Space Centre at Noordwijk in the Netherlands. Now, before we go, we'll talk to a trainee astronaut, but it should be remembered that the European Space Centre deals not only in the area of space research, but also in the area of telecommunications. And research in that area is going very fast indeed. A mobile phone for the next century should be available starting next year, in fact. The so-called smartphone will be a true personal digital assistant, or PDA. Voice, data, the internet, scheduling, even one-day video. A virtual PC in your hand. And all thanks largely to European computer and telecom companies. Arabic. British firm Xeon took a critical step this summer to have its software manage these new phones, signing up the giants of mobile phone manufacturing, Finland's Nokia and Sweden's Ericsson. Japanese and US partners scrambled to join in, fully aware that this European mobile phone standard could become the world standard.
We believe that we have the technology, we have the industry muscle and size, and our purposes through our shareholder agreements that we've constructed is to make this an open standard which we will license to all other companies.
Xeon, once thought by some to be an also-ran to Bill Gates and Microsoft, was chosen as the software provider of choice, in part due to the popularity of its handheld computers. Europe's mobile phone makers needed a computer partner, knowing Microsoft would soon be able to provide its own popular CE Windows product for phones as well.
On their own, even Ericsson and Nokia were finding it difficult getting to grips with Microsoft. They didn't want to give away the phone market, and therefore the only way they could compete was to get together, to pool their resources, and to produce a product which is better than the Microsoft CE products.
To be sure, Ericsson and Nokia are still bitter rivals. They fight each other in all corners of the world for cell phone dominance, and they will certainly do the same in the smartphone and handheld device markets. But the choice of one software provider saved the pain of a costly standards battle. At stake, billions of dollars. Mobile phone sales could top 300 million a year by 2002, and Europe wants to stay in the lead.
In terms of telecommunications, Europe have always been on the cutting edge, but in terms of computing and hardware, for many years now we've lagged behind the American players. It is good to see a European-based success story at last. What Bill Gates and his partners do from now is something which remains to be seen.
One thing Microsoft isn't doing, giving ground to Xeon. A Microsoft-based mobile phone will be on the way to rival Europe's offer. But for now at least, Europe's IT firms are dialing up success with their latest mobile technology wares. Well, I'm standing right now in a prototype of the research module that will be used by the ESA on the International Space Station that's being built. And I'm joined now by trainee astronaut André Kaupers. André, tell me, first of all, how did you become a trainee astronaut?
Well, I wanted to become an astronaut always, and I already started working in this area. And I applied in 1990, and I was an advert in newspapers, and then the whole selection process started, a long process. And finally, only recently, in the 5th of October, I got selected.
And so it's all very new to you. So what have you been doing since then, and how long will your training go on?
I'm a medical doctor by profession, and I worked for the European Space Agency already now for 7 years, coordinating medical experiments in spaceflight. In Space Lab and previously in the Mir. And from now on I will start training as an astronaut. It will first be a basic training in Germany, then there will be a specialized training for the station in Houston, and after that I'm ready and I will be assigned to a mission, and then you start training on specific experiments. Okay,
so you've actually been in this module before, familiarizing yourself with all the equipment that you'll be using. What kind of research do you think you might be doing
on the space station?
Well, there's different research, medical research, of course. We have material sciences. There's this big pieces of equipment here that can be exchanged with new missions. And we have also small pieces of equipment that will be brought up per experiment. This, for example, is equipment that is used by the astronauts to measure the oxygen in the blood. It's very simple, space qualified, and they use this together with breathing experiments or with exercise experiments to measure the oxygen content
and compare it with Earth.
Compare it with Earth, yeah.
And just an example of how everything needs to be tied down in space. We have here a toolbox, but not an ordinary toolbox. It seems here that everything has to be strapped down.
Yeah, that's one of the big problems of microgravity. It's a nice advantage for science because you can do good research, but the problem is that everything floats away, so everything has to be fixed. Here is two different systems to show how we can fix, for example, tools.
Mm-hmm. When you look back on why you think you became a trainee astronaut, what do you think singled you out from everybody else?
Well, it's hard to say what reasons are chosen to select somebody, and you don't know what is behind it. And of course, the factor that I already work in spaceflight and that I'm a medical doctor is probably also a reason, because they want people from all kind of disciplines. So there's military test pilots, physicists, engineers, and also medical doctors.
Well, congratulations and very best of luck to you.
Thank you.
Well, that's Inside Europe for this week. I'm Fionnuala Sweeney at the European Space Centre in the Netherlands. We'll be back at the same time next week.